Hi, I'm Brian Malow, and we are live from Lindau, Germany, the site of the 73rd Lindau Nobel Laureate meeting. And this year is a physics meeting, but it's every kind of physicist. There are 630 young scientists from 90 countries this year, and they're here to mix it up with about 35 Nobel laureates. I'm here speaking with one of our young scientists, Prachi Prajapati, and she is a observational cosmologist, not theoretical, observational cosmologist, an astrophysicist interested in the origin of the universe, right?
Yeah.
And originally from India, but working in Cologne, Germany. What institute?
I'm at the Max Planck Institute for Radio Astronomy, and I'm affiliated to University of Cologne at the same time.
And where are you in your career? What level?
I'm a first-year PhD student.
Excellent.
I did my bachelor's and integrated master's from India, Indian Institute of Space Science and Technology. I worked at the Indian Space Research Organization as a scientist after that, after my graduation for 3 years. And then I thought I am more interested in academia. So
Okay, wait. So that when you were doing that was space research, it wasn't really cosmology. What was it?
yeah, it was not cosmology, but I was still doing astronomy at some point, and then it was more like instrumentation as well as some research projects in parallel, but then not cosmology for sure. That's something new that I wanted to try out for my doctoral studies, and that's why I decided to come here at Max Planck and start my doctorate.
Excellent. So let me take you back farther. Did you always know you wanted to be a scientist?
In my childhood, so I was always interested in space in general, but not astronomy, to be honest. Like, I have never been that kid who looks into the sky
No?
and just worries about the stars being dead or alive, whatever. But yeah, at some point, like when I started my undergrad studies, I kind of got the feeling that astronomy is a field which is a mix of different physics, like including many different streams of physics, and that's the best part of it that I liked, and I got connected myself to it. And
Yeah. Let me have you
Yeah.
elaborate on that. Tell me a little more about what you love about science and what you love about astronomy.
I think for me it's more like intuitional knowledge that gets connected with, like, for example, if I do engineering, I don't get the feeling of like whatever is happening. I don't get the joy of doing the science. And astronomy on the other side, in general physics, like everything around me makes me feel that it's just physics and I should be understanding the nature of the phenomenons happening around, observe them, and know like how this whole life and universe came into the picture. So that's the motivation
Yeah.
with which I do this work.
And so let's talk about a little bit more about your research. So cosmology, a little more specifically, what sort of stuff are you working on?
So I'm working for my thesis about the star formation history over the cosmic time. So we are observing the high redshift galaxies from redshift 1 to 6, and we are trying to get the molecular gas mass. So
high redshift galaxies mean galaxies that are moving away very fast, and it means that they're very distant, right?
They are very distant. Yes, that's true. So these are the galaxies that were formed in the baby universe, for example, like when the Big Bang happened, and then eventually the first stars were born, and then they came together to form a galaxy, and those were the first galaxies that came into the picture. And we are basically looking back in time in that sense, and
Right.
trying to understand like how the star formation came into the picture, and eventually, of course, the Earth and the planets and the life that we see today that came
Yes.
up.
There's all this, in astronomy, one of the most exciting things in recent years has been the James Webb Space Telescope. And I've been hearing that, so much new information has been coming from, and a lot of it is about the earliest galaxies with the highest redshift,
Yeah.
most distant, and detecting galaxies so far back in time that it's hard to understand how they had time to form.
Yes, so of course, like last week I was reading the news from JWST, and they have detected some galaxy at redshift 14. So it's crazy, like when the universe was 200 or 300 million years old back then, and how this kind of galaxies can exist there. So that's one of the key open question, I would say, in cosmology, apart from knowing the nature of universe, being it expanding universe or accelerating universe. On the other side, like we are also interested in knowing how these large structures and big galaxies came into the picture.
Large structures being galaxies or
No,
galaxy
large
clusters?
structures can be the superclusters or clusters of galaxies.
Clusters
So,
of galaxies, and a supercluster is a cluster of clusters of
yeah,
galaxies?
exactly. So
It's
they have
crazy
long
that we have the
filaments.
ability to figure that out.
Yeah,
Isn't it?
so with time, I think humanity is improving the technological aspect of it and building new efficient telescopes like JWST. So let's hope for the best.
Is
Yeah.
there a question that, or questions that you most want the answer to?
Yeah, I mean, personally, I would definitely love to see the science going towards understanding how the life and the universe came into the picture in general, and how basically we can see that its nature and why it is like this. So
Yes.
that's, I think, the curiosity within all the physicists that are on Earth today. So,
Yes.
yeah.
You told me that you have an interest in science and physics in the developing world. Tell me about that.
So yeah, I came from India basically. So I'm from a country which was not like super developed like the United States or Europe in early times in terms of space science and technology. But I'm very like really proud how it has come about in the last many decades. Like India has been developing quite good missions for understanding the fundamental sciences and not only using the space technology for you know providing services to the public like agricultural research and climate research and understanding the communication part for the public. But on the same side, like we are exploring the moon now, going to Mars, so it's quite exciting that we
Very.
are spending money into fundamental sciences, and I feel like that's quite useful.
Excellent. And is there something that you wish more people understood about science?
Yeah, I mean, so what I feel is there is a little bit of language barrier in terms of how scientists talk and then how general public wants to hear about the science that we are doing. So of course with time having a lot of outreach programs that everywhere like now they are quite widespread and people like us are trying to communicate in more simple language to the public. So it's improving, I would say, but I'm definitely sure like everyone is paying tax in like public is paying the tax to the government, and that money comes to the researchers. So they all are, of course, very interested in knowing like what is happening and why we are doing what we are doing. So yeah.
Excellent. So let me ask you about your impressions of the meeting. We're still early in the week. There was the opening ceremony on Sunday, and yesterday, Monday, was the first full day of programming. And today, and by full, it's a full day. It starts very early.
Yes, for me it was really a full day program yesterday because I started at 6 in the morning. I had the breakfast in the morning for a partner event. And then I had like a lot of series of
Let
programs.
me ask you, right, the partner
Yeah.
breakfasts, there are a number of partner breakfasts. So the Lindau organization, there are a lot of partner organizations, and some of the things they do are sponsor these breakfasts. And there's a Nobel laureate. So who was your Nobel laureate at the breakfast?
I forgot.
Okay,
Sorry.
Bad question. Not sure right now. It was very early in the morning.
I know what he works on. He's the laureate from 2017. He worked on the laser technology basically, and the topic we were discussing was how science can be useful to help the humanity in 21st century and what we can do in terms of like helping directly to the society.
That's
Yeah.
one of the interesting things that it's built into the DNA of the whole thing, because the Nobel Prizes are not just given out to cool science discoveries or developments. That's only part of it. It has to be something that's of benefit to mankind. That's the language written into the idea of the Nobel Prizes. And it's the reason why Nobel Prizes are usually not awarded until many years, often decades after the work is done,
Yeah.
because you have to understand the context, the significance. So you come here, and of course the Nobel laureates. It's just so interesting that it's not just the Nobel laureates, though. These extraordinary young scientists, um, beyond their love and passion for the science, they care about the world. So many of them, they're not just obsessed with their science. They want to make a difference. Like, tell me
Yeah.
something about your motivations beyond your love of science.
So if I talk about the other sciences like quantum technology or being it chemistry or biomedical research, they have really like direct impact on the humanity. But on the other side, like if we talk about the fundamental sciences, so people might ask, like I have also heard many times like people asking why fundamental sciences are important, because they are not really directly helping the humanity. But one good example could be Albert Einstein's theory of relativity. Like if we see the GPS today, it would not exist if there is no theory of relativity, or you might be like off by many kilometers if you're traveling somewhere. So at some point, like of course this has implication in benefits of humanity. So all the
Yeah,
countries
people
should
often
promote
wondering-
the fundamental sciences are really cool.
Right, because there's sometimes people are like, what's the practical reason for this? And you don't know yet.
Yeah.
There may or may not be, but there really may be practical
That's
applications.
the thing, like
but you may not know
yeah,
yet.
Einstein didn't get the Nobel Prize for finding theory of relativity. So if he would have been alive today, he would have like had many big prizes
Right,
for doing
right.
that. Yeah.
'Cause he did win a Nobel Prize, but it
But
was
for
for the
something
photoelectric
else, yeah,
effect,
yeah.
yes, which was discovered to be very important.
So of course the patience plays important role, I think. Yeah.
Patience.
After a few years or even after decades, like your work pays off. That's what I have the motivation. Like you should do the best work and it will pay off sometime.
So tell me, a lot of people haven't heard about the Lindau Nobel Laureate meeting. So, to your friends and family, as you applied for it and got accepted and anticipating being here, how would you describe it to friends and family? That what is the Lindau Nobel Laureate meeting?
Yeah. So. Particularly like when I applied for it, I didn't have much expectations because I've never attended any such meeting. I've always been to conferences and meetings that are more astronomy related and more channelized in particular directions. But I would be really happy to say that this meeting is particularly quite open environment where you can talk about anything with anybody and no one judges you. You talk about chemistry with physicists or do the other way around, and it's perfectly cool. And that's how you get these innovative ideas and collaborative projects that you can discuss about. Even with the young scientists, like there are a variety of people from different countries and different work groups. So it's quite intuitive for me and very helpful. Yeah.
Excellent.
To
And
be in that kind of mode, it's really cool. Yeah.
before you got here, were there any things that you were anticipating, looking forward to?
Yeah, of course, like meeting Nobel laureates is one of the cool things that you can do when you're alive. At least if you don't get the Nobel Prize at some point, you can meet at least the people who won it and talk to them about their life and how they were motivated in their young career time. So that's really helpful to go ahead and keep the motivation on, I would say. Yeah.
And it is still early in the meeting, but have you had any highlights so far?
Yeah, yesterday was pretty productive for me. As I told, it was a long day. I started with a breakfast with the partner event, and then I had a walk with John Mehta, who is also a cosmologist. So it was pretty nice. Like we had chats about a lot of different projects and his life. So that was really cool. And then, of course, we had the Texas A&M dinner, which was the best part of yesterday. And I was sitting with Didier Queloz, who is also a Nobel laureate who worked on exoplanets. So, of course, extraterrestrial life and some cool stuff on the dinner table. Pretty cool, yeah.
Yeah, there are, someone might think it's just a science meeting, but it's so different. Each laureate generally gives a short 30-minute lecture. And it's not always about their research. Sometimes it's another topic. But in addition to that, there are all sorts of different sessions. And so you mentioned the science walk. one Nobel laureate and about how many?
10 students.
10
Yeah.
students walking around the lovely island and just talking freely about anything, right? Not even just about
Yeah.
science.
Even at the dinner table, like we were discussing the cooking skills of the everyone, and it was really nice that yeah, Nobel laureates also have like hobbies and their pastime activities, and it's really nice to talk about different things, not only science. Yeah.
Yeah. Well, thanks for taking the time to talk to me. There's so much to do here this week, and we've just barely started.
Yeah. Thank you very much. This was fun. Yeah.
Thanks.